Hello everyone. Previously we had discussed on the KMP algorithm, right? So today we'll be discussing on the topic Robin Karp algorithm, right? So let's get into the definition part. So now, what does the definition part say here? The Robin Karp algorithm is a string searching technique that uses hashing, right? So what it uses? It uses hashing to quickly find the occurrences of the pattern in the text, right? Again, the Robin Karp algorithm is a string searching technique that uses hashing to quickly find the occurrences of the pattern in the text, right? So it improves efficiency by comparing hash values instead of directly comparing the characters. Again, it improves efficiency by comparing hash values instead of directly comparing the characters, right? So this is fine. Now, let's go with the explanation part. So what we'll be doing within the Robin Karp algorithm. Let's see the same thing here. So normally, naive string matching compares the pattern with every substring of the text. We know this one, right? So when we go with a straightforward string matching, right? So what happens? We will be comparing the pattern with every substring of the text, which can take big of n into m time, right? So this we know, where n equals nothing but the n is nothing but the text length and m is nothing but the pattern length. This we know. This is naive or the straightforward approach, right? So what is difference in the Robin Karp algorithm then? Robin Karp improves this by computing the rolling hash for substrings of the text. Again, this is pretty much slower than the KMP algorithm, but it can be used for the multiple pattern matching. So this is very helpful for the multiple pattern matching. Just keep this in mind, man. Right? So Rabin Karp improves what it does. It improves this particular thing by computing a rolling hash for the substrings of the text. Right? So if the hash values matches accordingly with the definition that I said the same thing here, right? So it's a string technique that uses hashing to quickly find the occurrences of the pattern in a text. See here, Rabin Karp improves this by computing a rolling hash for substrings of the text. We know if the hashes values match, only then we compare the characters. If the hash values match, then only we'll be comparing the characters, right? Just to avoid the hash collisions. This basically makes it efficient with an average time complexity of big O of n plus m. Just remember this one, big O of n plus m, right? Simple. Now we are going with the this one Robin Karp, right? So function Robin Karp here, Robin Karp. Yeah, this is fine. So we have d equals 256, nothing but here, and q equals 101. So what is this? What are these values basically? 256 and 101 I have given here. 256 d equals 256 is nothing but the number of characters in the ASCII alphabet. Just remember this one, right? So I have already written this one algorithm. What happened is I tried to make a video that got stuck actually. I had already written the algorithm. So for this one particular video, I'll not be typing. I'll just be explaining the algorithm directly, right? So this is fine. Now this is nothing but the number of characters in the ASCII alphabet. Fine. So what is q is 101. So this is nothing but the prime number just to reduce the hash collisions. So basically what happens, why we will be making use of the Robin Karp and why it is pretty much dangerous means uh, this one, the hash, it can go with a hash collisions, right? So that is the only reason we'll be making use of the KMP mostly, right? So mostly in place of Robin Karp, right? So even though we can go with a multiple this one, what do we call, multiple pattern matching easily with the Robin Karp, even we make use of the KMP most of the times because it can get into the hash collisions part, right? So that is the reason. So here we have made use of the prime number to reduce the hash collisions. Remember this, right? So n is length of the text, so this is nothing but the length of the text, so this is nothing but the length of the pattern. Line number 20, p hash is 0 0, whatever I have given, this is nothing but the hash value for the pattern, hash value for the current text window. H equals 1, whatever I have given, so this is nothing but the multiplier used for the rolling hash. Now we have the idea. So now, whatever for loop I have written in the line number 25, this part, so we are pre-computing h equals d to the power of m minus 1, right? Modulo q, right? So this one, h equals uh, d to the power of m minus 1 modulo q. So that's what we are doing. So we are pre-computing h equals d to the power of m minus 1 modulo q. Just remember this one, right? So this is the pre-compute part. So whatever I have written in the line number 26. So this is simple for loop, man. You can understand this one. This is fine. Now let's move on with the line number 28. Whatever for loop I have written here, we are computing the initial hash values for the pattern and the first text window here, right? So again, line number 29 and 30. So here we are initializing hash values for the pattern and the first text window. This is fine. Now let's move on with the line number 32 here. So one more for loop here, right? So one more for loop, n minus m plus 1, whatever I have written here. So this one for I in range n minus 1, n minus m plus 1. So this one here, we are sliding the pattern over the text, right? So basically in simple terms within the for loop, what we are doing, if the hash matches, then we have to check the characters one by one, right? First of all, hash has to match, right? If only the hash matches, then we have to check the characters one by one, line number 33, right? So again, um, we're done with this part, right? So if the pattern is found, we are just printing this one for the this one interactive purpose, right? So pattern found at index, we are printing the index. This is fine. So now in the line number 36, what we are doing, if condition I have written, right? I less than n minus m. So here we are calculating the rolling hash for the next window. So for the particular window we have calculated, we have to move to the next window and calculate the same. We are calculating the rolling hash for the next windows. This one I don't have to explain more, right? So line number 36 and 37. So finally, this one, don't get confused. If t hash less than 0, whatever I have written here, so and t hash equals t hash plus this one equivalent to q, this one is nothing but we are converting the negative hash to positive. So at first even I didn't understand this part. Basically what we are doing here, we are converting the negative hash to positive here, line number 38 and 39, right? So finally we are going with the example usage here. So nothing but I have given some random string here, a b double c double d a e f g. Pattern that we want, that we need to match here is c double d, right? So we are just going with a function here, text along with a pattern, right? So what is the output that we need to get here? Mainly pattern. This is found at the this one, 2, index 2, right? So see here, 0 1 we have ab, so we don't need this ab. So pattern starts from c here, index 2 basically. This ends at somewhere. We are not going with the end, right? So we are not printing the end, we are just printing the starting. So starting, it starts from c here, and this c we will be ignoring. Only one c we want, basically c double d, right? So this one starts at the index 2 basically. So we have to get the output pattern found at index where? Index 2, right? So that is the output that we need to get here. Again, the text is here, this one. Pattern is cdd, right? So at the index 2, the substring cdd exactly matches the pattern. At the index 2, this one substring cdd matches cdd exactly matches the pattern, right? So basically we can just this one go with the output, or hence the algorithm prints here this one, pattern found at index 2. I hope this part is completely clear, man. Simple, right? Very simple. So this is it for the Robin Karp algorithm. So as we are done with the algorithm part, so let me quickly summarize whatever we have learned so far, right? So next we can discuss about this one. We have discussed on KMP algorithm earlier. Now we have discussed this one, Robin Karp algorithm, right? So next we'll be going with the Z algorithm or the Z algorithm, right? So this is fine. Now, let me summarize whatever we have learned so far. So, just keep these three things in the mind. Robin Karp uses hashing and the this one, rolling hash to efficiently search substrings. Again, Robin Karp uses what it uses, hashing along with the rolling hash to efficiently search substrings. Important, just keep uh, these things in the mind. So next thing is average case is big of n plus m, so making it much faster than the naive string search. Just remember this one as well. The third one is it is widely used in the plagiarism, this one, detection, search engines, as well as the DNA sequence analysis and multi-pattern searching. So mainly this one Rabin Karp algorithm is used in the multi-pattern searching, right? So this is used in the multi-pattern searching. As far as I know, I have used the Rabin Karp algorithm for the multi-pattern searching itself, right? So I'll not lie. Other things I don't know. I haven't used. So this is widely used in these four cases, right? So plagiarism detection, right? So this one, if I copy, nothing but the plagiarism detections, right? So this is fine. Search engines also will be making use of the Rabin Karp. DNA sequence analysis, for that also will be making use of the Rabin Karp. Finally, for the multi-pattern matching of multi-pattern searching, right? So this is it about the Rabin Karp algorithm. Next, we'll be discussing on the Z or the Z algorithm. For now, this is it. Thanks for watching, guys.